Hello scrappers, and welcome back to my channel. Today I'm going to show you how to turn that nasty goo into that. That is an ingot of solid copper. It weighs 3.5 pounds that I poured by melting that stuff down. And what is that stuff? Well, that is the remains in the bottom of my chemical waste bucket from recovering gold and silver from IC chips for a year and a half. And you know, I have a stock pot. The remains, the liquid that left over after getting the gold goes into the stock pot. I keep that full of copper. The copper dissolves in the stock pot and cements out any precious metals left in the liquid that goes in it. And then the liquid, when the stock pot is full, gets decanted off into a waste bucket, and the waste bucket is kept full of iron and steel. And what happens is the iron and steel dissolves and any copper cements out on it. So you wind up with a bucket full of cement copper in the end. Here's a kind of quick and dirty diagram of my liquid waste processing system, just so you know what I'm talking about here. I've got a stock pot that all of the liquids from my gold recovery go into, and I keep scrap copper in the stock pot. And any precious metals left in these liquids will cement out on the copper and wind up in the bottom of the stock pot. Now, over time, the stock pot fills up, and from time to time, I will let it settle, and I will decant off the liquid into the waste bucket. And the waste bucket is what we're talking about today. And into the waste bucket goes not only the overflow from the stock pot, but also any waste copper nitrate solutions I'm creating when I'm dissolving the base metals out of IC chips as I'm processing those. So that goes in here. And I keep scrap iron and steel in the waste bucket. And as a result, the copper in the liquid cements out on the iron and steel and collects in the bottom of the bucket. And from time to time, I have to change to a new bucket because eventually the bucket fills up with the cement copper. And then, you know, just to give you a sort of capsule view of the whole waste process, liquids from the waste bucket, after I let it settle, will go into a treatment system. It's more of a tub than a bucket. And I'll adjust the pH, and a lot of solid metal hydroxide compounds will settle out. And that can be disposed of, and the liquid can be disposed of then. It has no heavy metals left in it. So that's the whole waste treatment process in a nutshell. But we're talking today about the cement copper that collects in the waste bucket in the middle of the process here. So I've been struggling with what to do with this cement copper. I mean, up till now, I've just been throwing it out when the bucket's full. But I've been experimenting pretty heavy with the contents of this bucket ever since I switched over to a new waste bucket. So I've been trying to melt it down and make bars out of it. I've been trying to do other stuff with it too. And as you can see, I am somewhat successful. I've got a nice bar of copper right there ready to go to the scrapyard and make some money, or put into my stock pot and keep the cycle going so I don't have to obtain fresh copper to put in the stock pot. So either way, you know, it's a win. So here's a look at the kind of stuff we're dealing with. This is some stuff I scooped out of the waste bucket there, and I've washed it a couple of times so you can get a better look at it, because there's a lot of crud in the waste bucket. And you can see there's some debris in there that's not copper, but there's a lot of copper here. There's a lot of copper here. Nice spongy cement copper. So, but we're going to have some debris to deal with, and that's going to be a problem. I mean, there's paint chips. There's who knows what all went into that bucket with the iron and steel I put in there. And there's another issue, which I'm going to have to deal with, which may or may not be an issue for you. Let me go look at my current waste bucket, and I'll show you the problem. So here's my current waste bucket. It opened up. And get a focus here. You can see I've got some steel in there that's slowly decomposing and cementing out copper. Now, most of the steel scrap I get is galvanized. So I'll tell you what, the galvanized steel works really good for cementing out the copper. The copper really reacts strongly with the zinc coating on the steel. And I'll tell you what, if I was to dump, you know, a fresh batch of copper nitrate or copper chloride in here, the reaction would be very vigorous and intense until all that zinc is gone. Then it would slow down a lot. The problem with that is, now I've got zinc compounds in here. And when we go to melt this cement copper that comes out of here, we're going to have some zinc in it. And the zinc is going to outgas at the temperatures that I got to get it up to melt the copper and melt the slag, melt the crud in here into a slag. So we're going to have some zinc vapor coming off. So I'm going to wear a gas mask while I'm doing this. If you don't have significant zinc in your copper, you probably don't need to wear a gas mask, although it's always a good idea when you are melting metal to wear one. So here's another experiment I decided to try with my cement copper. After casting some bars out, I decided to do a little electrolytic refining. So check this out. I hope that's showing up nice on the camera. Look how fat that wire got. Yeah, so here's a little close-up of it. I mean, the wire's gotten to at least double, some places maybe close to triple the original thickness. And it's got some crystals on it, crystals of copper. My camera doesn't really want to focus that close. And electrolytic copper, electrolytically refined copper, is like 4/9 fine. So very, very pure copper. So this is some very, very pure copper I'm making here. Not really sure that I need copper this pure for anything. It's just an experiment I'm doing, just, you know, playing around with my cement copper because I've got so much of it. So what I will probably do is just keep this going for a while and see how big I can get this. My little power supply over here can only put out about 1.5 amps tops, so this is only, oh, I don't know, maybe 12 hours of running at 1.5 amps. Should have weighed the wire before I put it in, and weigh it now and see how much copper I've got on it. I'm using copper nitrate as an electrolyte. I have plenty of copper nitrate. That's where the cement copper comes from, after all. So it's working pretty good as an electrolyte. So I don't know, I may play around with electrolysis some more. I'm thinking if I could scale this up, you know, get a power supply that could supply a lot more current, I could scale this up. What I could do is purify my copper, you know, my somewhat impure bars. Probably good enough to sell at the scrapyard to put back in my stock pot, but they're by no means pure copper. What I could do is I could purify my bars by electrolytic purification here, and what will happen is all of the impurities will wind up on the bottom of the beaker in what's called the anode slimes, including, hopefully, some precious metals. And believe it or not, in the copper industry, they purify the copper electrolytically. All the copper you're going to get is electrolytic copper. And most of the gold and silver produced in the world these days comes as a byproduct of copper electrolysis in the anode slimes. They actually get more of it that way than they do mining the gold and the silver out of the ground. So, kind of interesting. I was thinking if I wanted to purify the copper, I don't know if I would get anywhere near enough precious metals out of the anode slimes to pay for the electricity and miscellaneous whatnot, but it might be an interesting experiment to try if I could scale it up. So that might happen in the future. So here's the stuff we're going to be working with. I don't know if the copper color is showing up on the video. Can't see the finder very well in the sunlight, but what I did was I scooped this out of that waste bucket. I've given it a few tap water rinses just to get the bulk of the crap out of it, the lightweight crap. It's still pretty dirty stuff, but I washed a lot of crap out of it. I also pulled out any lumps and chunks of undigested iron and steel that were in it. I'm sure there's still some iron and steel in there, but I got the big chunks out. In fact, I think I see a bolt right there, or a nut right there. So there's still some iron in there, I'm sure. but copper is a lot more dense than iron, so the iron will float on top of the melted copper, and I'm not going to get the foundry hot enough to melt the iron, so I don't have to worry about it melting and alloying with the copper. Really, it's going to float on top. So this is what we're going to be working with. Okay, let's melt some of this copper and make some bars. I've got my little home-built foundry over here, propane tank, propane burner. I've got a crucible, and I've dried out that cement copper powder that I showed you earlier. I just left the bowl in the sun for a couple days, and it's nice and dried out. So I'm going to fill the crucible pretty much to the top with this stuff. So my experience with this is that this stuff's going to melt down to the point where the crucible is only about half full once it melts. So we'll be able to add some more later. It's important though, if you're going to add more, that it be dry. You don't want to put the wet copper powder in a crucible full of molten metal, or you will have a steam explosion and it'll blow molten metal all over you. So I've got some good old 20 Mule Team borax here. I'm going to put a couple of spoonfuls of that on top. And this is going to serve a couple purposes. The borax will melt first, and as the other stuff melts in there, there's a lot of impurities. It's not pure copper. There's a lot of impurities in there. And it'll melt to form a slag, and the borax will reduce the viscosity of the slag, make it more liquidy, so that all the little droplets of molten copper can pass through the slag and get to the bottom. And then all the impurities will be floating on top in the slag. So when we pour our ingots, the slag will float on top, and it'll be a brittle, glassy-like stuff, and you can just chip it off real easy. I've tried this without the borax, and what I get is a foamy mass of ugly. So the borax helps a lot. So I'm going to put this into the foundry furnace, and we'll get it lit up. Okay, we'll get her lit and get the lid on. There we go. This will help hold the heat in, get it hotter quicker. So we just gotta let this warm up now. I'll go get the ingot molds and get them ready too. Okay, there's our graphite ingot molds, and just before we're ready to pour, I will put them up on top of the foundry furnace and let them get good and warm before I pour, because you never want to pour molten metal into a cold mold, because if there's any moisture in those, again, you'll get a steam explosion. It'll blow the copper out all over the place. It's burn city when that happens. You don't want that. And it's been a humid, foggy morning, so I wouldn't be surprised if they're a little damp. So I'll put them up there, heat them up, and get the moisture out of them. And once we're getting ready to really deal with what's going on in the furnace, I'll have to put my respirator on, just so I'm not breathing any zinc vapor or any other nasty vapors that are going to be cooking out of that impure copper in there. So if you're doing this, I highly recommend wearing a respirator as well. So you'll probably have a little trouble hearing me. I will add captions down at the bottom. Hopefully everyone watching this is literate. So it's been going for a few minutes, starting to get good and hot in there. I don't know if it's showing up on the video or not out here in the sunlight, but there is a nice blue-green flame coming out of the top of the foundry furnace. And I'm sure that green is from the copper. Some of it's volatilizing as it heats up in there. Kind of pretty. It's going to take a few more minutes before it starts to melt. It's not quite that hot yet. Okay, so the stuff in the crucible, I'm not going to get the camera too close. It is really hot over there. I got to put on some PPE and go over there. I'm going to take the lid off. Well, first what I'll do is I'll shut the fire down just so it's not roaring up in my face. Take the lid off, and I'm going to dump the rest of the powder in the crucible because it has melted down to where it's about half full again, like I said it was going to. And then we'll put the lid back on, turn the heat back on, and we'll let it melt the rest of the way. Then we'll be ready to pour.
Okay, here we go. Burner's off. Burner's on. Let that melt down when you're ready to pour. In the meantime, heat these up. Drive any moisture out of them.
Look how green that flame is. Kind of neat. So I don't know if you could hear me when I had my respirator on. I am warming up the graphite molds to get any moisture out of them, so we don't have to worry about a steam explosion. Because we're getting close to being ready to pour here. Once that bit of copper I just put in there melts down, we'll be ready to go. Okay, we've reached the temperature where where zinc has started boiling out of the copper. So I've turned the heat back down. I think we're ready to pour. I get my gas mask cinched up here so I don't breathe any of that zinc vapor. And we'll be ready to go. A lot of slag left in there. I'll have to reheat it and see if I can pour that slag out of there so I can reuse the crucible. Pretty well. Looks like I've got two halfway decent ingots there. There's a lot of slag left in the crucible. I don't know if you can hear me say that. There, maybe you can hear me a little better now. There's a lot of slag left over in the crucible. I'm going to reheat it and see if I can pour it out. It's pretty viscous. Maybe I should have used more borax.
Anyway, let's see if those ingots will come out of the molds now. They've had a chance to cool a bit. Okay, got 2 good ingots out of that pour. So I'll just heat this crucible up and pour the slag out, and it'll be ready for another pour.
Okay, that went pretty well. Sometimes the slag's a little more viscous and it runs out first and fills the mold. Usually when I pour these ingots, the first one I pour has a lot of slag floating on top of it. This time the slag was more viscous and it stayed in the crucible while the copper poured out around it. That was kind of unusual. It doesn't usually happen that way. I probably didn't use enough borax, so the slag was very viscous. Hopefully I can get it out of the crucible for reuse. I might have to put some more borax in it and heat it up and let it all become nice and liquidy. But I got 2 good nice ingots out of it. Not a huge amount of powder there. So that went well. Didn't break any of my molds. They can all be reused. We're doing good. Alright, I have changed my mind about the slag in that crucible. After reheating it and adding a little more borax to it, it's a nice liquid layer on the bottom of the crucible. As viscous as that slag was, there's probably still a lot of copper in it that didn't make it to the bottom and coalesce. So what I will do is I'm just going to leave that slag in there. Now it's nice and liquid, and the next time I pour some bars from my cement copper, I will just fill the crucible up with it and maybe put a little more borax on top. And then I should be able to get all of the copper out, including whatever stuck in that formerly viscous slag. All right, enough with the foundry. Let's move on and take a look at what we've done here. Okay, so this cell has been going for about 3.5 days, I guess. Now, it hasn't been going the whole time. It's just been running it during the day when I'm out here in my workshop. I wasn't going to run it at night because all these little copper dendrites coming out. I was afraid if I just let it run unattended, I'd wind up with a short across the, see how that copper's growing out of there? I was afraid I'd wind up with a short between the cathode there and the anode. So this has been pretty darn successful, considering that I've been running at pretty low current. I mean, I started out with about 1.5 amps. And about halfway through the experiment, I upped that to 3 amps. Only at about 2 volts, though. That's the voltage across the cell, about 2 volts. So there's a lot of copper here. This is very heavy. I think I said before, I should have weighed it to see just how much copper I have plated off of this copper bar I poured. I mean, and it looks like hardly anything's come off the bar, but there's a lot of surface area there, so a lot of copper could come off that and you wouldn't really even notice. And I don't know if it's showing up on the camera, probably not, but there's a layer of scum in the bottom of this beaker, and that's going to be the anode slimes. So if there are any precious metals in this bar of copper over here left in it, they're going to wind up in the bottom of the beaker here in the anode slimes rather than in this, because only copper is going to plate out on this. So I'm thinking, and I might do this in the future, this is just a, a small scale experiment. I'm pretty happy with the way it's gone so far on the small scale. In fact, I think I'll put it back together and run it a little while longer. Put this in here, the beaker, very gently so I don't blow the bottom out. I think I'll run it a little while longer. And what I'm thinking about is if I really wanted to, I could scale this up a lot. I could have alternating ingots of my poured copper from my waste bucket, and then copper wire cathodes, and just alternate them in a bin, say a plastic bin. Ingot, copper wire cathode, ingot, copper wire cathode, ingot, copper wire cathode. I'd have to come up with a power supply that could put out enough current at a couple of volts to move a meaningful amount of copper in a short period of time. But I've got some power supplies in the back that I think would work with a little modification. And yeah, I could plate out a lot of really pure copper and collect a lot of anode slimes. And if I get enough of that, I can start processing it and see if I can get any precious metals out of it. I mean, there's probably some gold, some silver, some platinum, some palladium, other stuff down in here. So there's not a lot in here right now, but if I did this on a large scale, I'd produce a lot of anode slimes and maybe be able to get some precious metals out of them. Whether it would pay for the process, I don't know. It might not. But it would be an interesting, experiment. And I'd have some ultra pure copper, which I could put back in my stock pot and start the process all over again. I think I could probably just put these bars as is in my stock pot, so I'll have plenty of both. I mean, I'll have bars I can drop in the stock pot, and I'll have ultra pure copper I can put in the stock pot, and I'll have anode slimes to play with. So we'll see if I ever get to that point in the future where I really scale this up. It might happen. It would be a very interesting experiment. Whether it would be cost effective, considering the cost of the electricity and the cost of the propane for melting the copper, I don't know. I'd have to do some figuring, some ciphering, as Jethro Bodine would say. Some anses and some gazintas. But it would certainly be an interesting experiment. So we'll see if that happens. Oh, and by the way, the roar that you may be hearing in the background, that's the foundry furnace going, melting some more copper. Okay, now I will be the first to admit that these are not the prettiest ingots of copper I have ever seen. Pretty ugly, kinda. Okay? Now, you can clean them up a little bit, like I did with these two here, just by hitting them with the wire brush, or the wire wheel in my angle grinder is actually what I did. So that kind of shined them up a little bit, but they're still pretty ugly. If you really want pretty ingots, now, which I'm not aiming for pretty ingots, these are good enough for me. These are going to go back in my stock pot just to keep the process going. I might wire brush these just to get the crud off of them so they're a little shinier and got better surface for the chemicals to attack, but that's about it. I might use them as anodes in a refining cell just to try and collect some anode slimes. We'll see. But for me, they're good enough. If you want to make pretty ingots, though, what I would suggest is a clean crucible, a nice clean crucible. Put all your ingots, your rough ingots in it, and remelt them. Wire brush these first, get the crud off. The first melt got rid of almost all of the impurities. So we've pretty much just got copper here. So if we remelt these in a clean crucible without the flux, we should get a really clean pour of copper. And also, you can throw any other scrap copper you've got laying around in here and add to this. Like I had a whole bunch of the heat sinks from these Pentium processors. And these heat sinks, they're solid copper. I didn't know if you know that. And they come off real easy with just a hammer and chisel. But before you melt them, run them through the Eco Gold X Gold Stripper, because they're usually gold plated on the back. So they make so that the die can be attached to them with brazing. They're usually gold plated on the back. But yeah, these melt down and make nice copper ingots too. If you've got a bunch of them, I melted down several pounds of them a while back. And let's see, I've got other scrap copper around. I could throw in here if I wanted to melt this down and pour really, really pretty nice ingots. Especially again, if I went at them with the wire brush afterwards, or even a sander, they would be gorgeous. But you know, these are good enough for my purposes. So that's as far as I'm going to take them. I'm not going to waste the propane and the time trying to make them pretty. But if you want to, that's up to you. Anyway, this is how I deal with my cement copper that comes out of my waste treatment bucket now. I think this is a pretty good process. You know, it doesn't cost much. I already had some crucibles here. I've been melting metal for years, so I already have crucibles. Already had the foundry furnace, a little bit of propane. That's it. I got copper ingots. So thanks for watching. I hope you found this video at least a little bit interesting, informative, educational, whatever. Give the video a thumbs up, give it a like, and subscribe to see future videos. There will be more videos coming out on lots of different subjects. And press the little bell icon that YouTube makes you press so you get notified when those new videos come out. And thanks again for watching. See you around.